Hi guys, welcome back to this video. We will clear here understand the difference between the combinational circuits and the sequential circuits. So far we have explored various combinational circuits like adder, subtractor, multiplexer, decoder and encoders. But now it's time to move forward. This video is bridge to the sequential logic where memory and timing matters here. Let's begin and compare the stage for understanding flip-flops and sequential circuits. So let's get started. So if you think one thing, so we have already the thing called logic gates. So with the help of the logic gates, we can build any of the logic we want. Yeah, the logic gates is the basic thing. But with the help of the logic gates, only the combinational circuits and sequential circuits are made of. So we already know about the logic gates. There are total 7 logic gates, including the universal logic gates. So just inputs and outputs. So with the help of logic gates, we will see how we can combine. We already saw in the combination circuits. But let's just in this video we are going to just understand the difference between combinational and sequential circuits. So let us understand the difference between combinational and sequential. Let's start with the combinational circuits. So combinational circuits means we have some inputs and some outputs. So inside the box we don't know what is there. So according to the thing that we are going to plan what is inside that box, according to the logic we will place logic gates and some logic inside. So the main thing here is output is only depends on the present input. If you observe the inputs are coming, output is going, input coming, output going. That is the process main inside this. There is no feedback, there is no memory element for storing the output. So that element, so this is the thing that I can say. You can see that points also. That is very important point. There is no memory element in this. Because if you have memory element, we can store and we can give feedback for that element. So without storing, just it will produce the outputs by passing the inputs. That is the main thing in combinational circuits. So now let's understand what is meant by sequential circuits. So in the same way, output is depends on present input. Yes, it is the main thing. And also in these sequential circuits, it's also depend on previous output. Next here memory elements required and feedback is applied to the next output. So by studying this you might not understand. If you see the circuit diagram then you can understand very easily. But just remember the previous output is also again added to the input so that the next output will be produced. So this is the logic of the sequential circuits. So this is the main difference between combinational and sequential, and remaining things are same. And also feedback is there in this, memory element is required. So for the memory element we are going to use the flip-flops. So we will see in the upcoming video the flip-flops. So before that, these are the two parts in the digital electronics, combinational part and the sequential part. So in the sequential part, so we have to understand that clock pulse is also there. So according to the clock, the output will vary. So that is the main thing, another main thing in the sequential circuits. But in the combination circuits, only the present input is there. So that is the reason we do not use the clock, or the output will not be dependent on the clock pulse. Now first let's see the circuit diagram for the both combinational and sequential circuits. So we have already discussed about the combinational circuits. Just inputs are coming, outputs are going. So let's observe clearly the sequential circuit. If you observe there, we have one combination circuit over there. For that combination circuit, we are passing input and we are getting output. The same thing that we already know. But for the combination circuit only, the output we are again passing into a memory element. So those memory elements can be anything that is flip-flops like JK, SRT, like that. It can be any of the flip-flop. So the next upcoming videos is based on the introduction to the sequential circuits, and next videos would be on flip-flops. So memory elements are that main thing for the sequential circuits is memory elements. Again the memory will be feedback to the combination circuits. So memory can store at least 1 bit, means maximum 1 bit, that is 0 or 1. Again it will be refreshed with the combination next output, next present input, next output, like that it will change according to input. Now let's see the examples of the combination circuits and sequential circuits. So we have already discussed these all things in this playlist only. That is combinational circuits. In that we have discussed subtractor, full adder, full subtractor, multiplexer and demultiplexer in detail we have discussed. And parallel adder and carry look ahead adder, decoder, encoder and code converters. So these are the things that are all covered in this combination circuits. So if you see in the sequential circuits, so flip-flops, shift registers, counters. So in the counters only we have many more types. By seeing this we can see only 3. No, in this only there are many subtypes. So these are all things we are going to see in the sequential circuits only in the upcoming videos. And one more important thing, if anything that we want to measure or the output is required, how we can do that? So for the process, simply I can say the procedure, how to do the procedure. So if you consider the circuit diagram, so in the combination circuits we call it as circuit diagram. In the sequential circuit also we sometimes call it circuit diagram, or according to the in the sequential circuits we have something called finite state mission. For that, in that we are going to call it as state diagrams. So anything we can call. So the heart and soul of the combination circuits is truth tables. So sometimes some of the cases without the truth tables it might not be possible for the simplest possible answer. So for the any answer, any Boolean algebra, any formula, we just confirm with the help of the truth tables. So in the sequential circuits also, we call them as state tables, not truth tables. We call them as state tables because here there is the thing called present state and the next state, because here memory is involved. So that is the thing that we are called it as state tables. So in the exams they will give the circuit diagram, they will ask the output expression like that, they might be asked. So according to that I am going step by step. So first they give the circuit diagram, so that I have discussed. Next time we are going to analyze the truth tables, so from the circuit diagram that also we analyzed. The next that we are going to see the output expression, that we are going to formulate the output expression with the help of the truth tables. So that also I did in the two steps. With the help of state table, in the help of truth table I have formulated the output expression. After getting the output expression, the required solution and according to the question in both combinational and sequential circuits. So if they already given the solution, again they ask to formulate the circuit diagram. Vice versa also we can travel. Suppose they have given the final solution they have given. From that we can formulate the truth table. From that we can formulate the circuit diagram. We can go back. In the sequential circuit also, that is the main thing. So in the sequential circuit only we can go back. That is the if anything output expression is given, we can go back, we can formulate the state tables and we can formulate the circuit diagram. So these things are very important. These kind of questions might be asked in your university exams, because in our exams they have asked that. So that is the thing that I have mentioned here. So be prepared with this kind of things that we are going to discuss. We are going to tackle this kind of things in the upcoming videos. So I hope you understood the difference between combinational and sequential circuits. Thanks for watching up to now.